Good afternoon, everyone. I am Dr. Prasanta Kumar Guha, Associate Professor in the CE Department of IIT Kharagpur. Today, I would like to give a talk on WO3 Nanoplates based Chemiresistive sensor device for selective detection of 2-propanol. The co-authors of these papers are Mr. Snehanjan Acharyya, Mr. Bibhas Manna, and Dr. Sudip. So, of this talk, the outline of this talk is I will first introduce the gas sensor to you. I will talk about synthesis of nanomaterial. Here we have used WO3 Nanoplates. Show you some material characterization. I will show you device fabrication. We have done some gas testing, particularly using 2-propanol. I will show you some results. Talk about sensing mechanism. But the sensors are not selective. We have done some testing with other VOCs. So, we have used machine learning algorithm to improve the selectivity. Show you some results on that also, and at the end I will conclude my lecture. Modern society, particularly the urban environment and industries, industrial areas, they have lots of toxic gases, inflammable gases, and this is particularly true for developing countries and underdeveloped countries. Apart from toxic gases, there are poisonous VOCs, for example, that is volatile organic compounds, for example, formaldehyde, 2-propanol, ethanol, acetone, toluene, and so on. As far as the micro-resistive sensors are concerned, metal oxides are the primary sensing layer people have been using, because they can sense gases with repeatability and gives quite large response. However, metal oxides are poor in terms of selectivity. So, what we have done in this particular work, we have used sensor to detect 2-propanol. 2-propanol is a VOC which is extensively used as solvents for antiseptics, cleaning agents, paints, polish, and cosmetics. And to improve selectivity, we have used pattern recognition techniques and different machine learning algorithms. So, this is the synthesis procedure we have adopted. We have used Na2WO4 dihydrate and NaCl. We mix them in DI water. We have stirred around 15 minutes to make it a transparent solution, and then we have used around 1 milliliter of HCl drop by drop, then stirred it for around 6 hours in a magnetic stirrer. Then we transferred this solution in an oven around 40 degrees centigrade. We have kept it for 12 hours. Then we have transferred the solution in a Teflon lined autoclave, basically a stainless steel chamber, and kept it in an oven around 24 hours at 90 degrees centigrade. So, at the end we filtered it and washed it repeatedly in DI water, and we calcined it around 400 degrees centigrade for 2 hours. So, that basically gives us WO3 nanoplates. And we use these nanoplates for the sensing purpose. So, that is our sensing layer. So, this is basically a hydrothermal approach. So, we have characterized our nanostructure. These are nanoplates in FESM image. Typical dimension length is around 325 nanometer, and thickness of the individual plates is around 200 nanometer. We have done XRD study also. You see different peaks correspond to different crystal plane of WO3. So, it's like there are polycrystallinity occurring in our material. So, as I mentioned, I have used this material for developing chemiresistive sensor. So, this is our sensor device. The substrate is basically a glass substrate. We have used conventional lithography technique and evaporator, thermal evaporator to realize IDs, that is interdigitated electrodes made of aluminum. and we have used WO3 powder dispersed in DI water and a simple drop cast technique to realize our device. Dried it around 50 degree centigrade for an hour. Now, this sensor is used in our custom made gas test setup. Schematic is shown here. So, there is a dry air chamber, there is a analyte gas chamber. In case of VOCs, you need to use a bubbler. So, the dry air will go through the bubbler and carry the VOC with it. We have a digital mass flow controller to control the concentration of analyte and gas or the VOC we are testing. The digital mass flow controller is from Alicate. So, this ultimately these gases and VOCs and the dry air is going through a mixer and reaching the our sensing chamber where the sensor is housed. The sensor is then interfaced with a parametric analyzer, and we can collect the data, the real time data, and see it in a computer. So, this is basically our sensor setup. Now, I would like to show you some result in case of 2-propanol. We have found that the sensor is the optimum performance is obtained around 250 degree centigrade. So, all the characterization was done at 250 degree centigrade. We have used 4 concentration of 2-propanol, 25 ppm, 50 ppm, 100 ppm and 200 ppm. The way the sensing was done, we use the gas, and then after certain time we switch it off and pass dry air, and that brings the sensor to a baseline, and then we use a different concentration. So, the more the concentration, the response, the more we got the response from the sensor device. Here by response I mean Ra by Rg, that is resistance of the sensing layer in presence of air over the resistance of the sensing layer in presence of gas. So, with increase in concentration, the resistance of the sensing layer reduces, so that increases the response. The sensor performance was quite good. We found around 4.31 times of response at 200 ppm of 2-propanol, and it is shows the sensor is very fast. It gives response time around 70 seconds and recovery time around 115 seconds at 200 ppm. We used other VOCs also. For example, we used toluene, ethanol, acetone, formaldehyde apart from 2-propanol, and we have found that 2-propanol is selective. However, if we reduce the concentration in 2-propanol and increases the concentration of other VOC, you can see that selectivity will degrade. So, to improve selectivity, we have done some machine learning algorithm. But before going into that, I would like to describe you the sensing mechanism. We all know that in presence of air, metal oxides becomes highly resistive because the oxygen in the air trap or extract the electrons and form oxygen adsorbates. So, now when reducing gas come in contact with the sensing layer, in fact come in contact with these oxygen adsorbates, they basically releases electron. So, electrons will go back to that sensing layer, reducing the resistance. So, that is basically the standard metal oxide mechanism, how it is sensing the gas. Now, as I mentioned that we have done some machine learning algorithm. So, for that what we have done, we have used 4 VOCs: formaldehyde, 2-propanol, ethanol and acetone. We have not considered toluene because you will see that the response from toluene was pretty poor. So, these 4 VOCs we have used. We have used only 4 specific concentrations: 25 ppm, 50 ppm, 100 ppm and 200 ppm for all those VOCs, and specific temperature of operation 200 degree centigrade, 250 degree centigrade, 300 degree centigrade and 350 degree centigrade. So, I have plotted all those characteristics. So, for example, the left hand one was response versus temperature for all 4 VOCs. You see that response characteristics, although for example for formaldehyde and ethanol looks similar, okay, but their optimum temperature is different. Similarly, I have plotted response versus concentration for 4 VOCs. We have plotted response time versus temperature, response time versus concentration, and also recovery time versus temperature and recovery time versus concentration. So, I have put all these data in my algorithm, and what we have done 80% for data for train set and 20% data for test set, and we have found that random forest, naive Bayes, and SVM and ANN, out of these four machine learning algorithm, ANN gave the best results as far as the selectivity is concerned. So, these are all confusion metrics. So, at the end I am summarizing my talk. So, WO3 nanoplates were synthesized in this particular work. We have used to detect 2-propanol, and 2-propanol give quite the sensor give quite good response, around 4.31 times at 200 ppm. However, the selectivity was not good. For that, different algorithm was used, particularly ANN gave 100% accuracy. At the end, I would like to acknowledge IIT Kharagpur, particularly Center Research Facility, for giving us the opportunity to characterize the nanomaterials. I would like to acknowledge also DST, that is Department of Science and Technology, under MEITI, and for NNET or NanoNetro project, and also ACRB, that is Science and Engineering Research Board, for the project Indoor Air Quality Monitoring, IAQ. Okay. So, thank you very much, and I am ready to take questions.